One of the most intriguing questions we've all wondered about when we were kids is whether we can travel into the future or go back in time using some sort of time machine. This question still remains intriguing even in our adult lives, and fortunately for us, science has advanced to the point where we can answer this age-old question. We can easily travel forward in time, and we've known how to do that since 1905. Einstein's special theory of relativity lays out the whole recipe of how you can move into the future. All you have to do is go into a lower gravity field relative to other people or just travel very fast, and your clock will tick slower than that of everybody else that you've left behind. Then, when you return, you'll be younger than your twin. For example, if you had left your twin back on Earth. So, in that sense, you are traveling into the future. That's easy to do, and we've known how to do that. Traveling backwards, however, that's the problem. We think we can do that. I have some colleagues who've made some calculations that suggest that depending on the trajectory you take around a black hole, you can come out and end up in the past of when you started. But that takes an extraordinary setup to make happen. Right now, there's no problem traveling into the future. We've known the answer. It is absolutely possible to travel forwards in time. In fact, we have irrefutable evidence to show that. So before we dwell into the intricacies of going back in time, let's see why scientists are so confident we can travel into the future. The faster you move, the slower time ticks for you, as others view it, relative to the observer. You don't know anything's happening. Your clock still ticks, as far as you're concerned. You've still got your heartbeat, all of this. So this is not a physiological thing, it is an actual property of the fabric of space and time under those conditions. So I watch you fly by, and the faster you go, the slower time ticks for you. Not only does speed do this, but also the strength of a gravitational field will have the same effect on you. Initially, when formulated, you think it's just because you're moving, but it's actually way deeper than that. The GPS satellites orbit higher than our space station. The geosynchronous satellites are like middle orbit, that is, far enough away from Earth's source of gravity for them to have a measurably different spacetime condition. Their clocks tick faster than our clocks on Earth's surface. Because they're farther away, their time ticks faster relative to us. But we get precise timings from geosynchronous satellites. How does this work? We've pre-corrected the time signal from the GPS satellites to compensate for Einstein's general theory of relativity so that by the time the time reaches us, it's been properly corrected. And it matters to us and our spacetime continuum, not the one that's in middle Earth orbit. Once you calculate that, then you do and you say, oh my gosh, the formula works. Einstein was right. It is true in physics, and relativity time dilation is the difference in the elapsed time measured by two clocks, either due to a relative velocity between them or due to a difference in gravitational potential between their locations. For example, near the vicinity of a black hole, to a distant observer, clocks near a black hole would appear to tick more slowly than those farther away from the black hole due to this effect known as gravitational time dilation. An object falling into a black hole appears to slow as it approaches the event horizon, taking an infinite amount of time to reach it. As we said, besides the difference in gravitational potential, there is another way to travel into the future, and that is by going through space at relativistic velocities. As you approach the speed of light, something really strange starts to happen. Let's keep going faster and faster, 90% the speed of light, 99% the speed of light. Time is ticking slower and slower and slower for you. You will watch the whole future history of the universe unfold in front of your eyes as fractions of a second go by for you. As you go 99%, 99.9%, 99.99% the speed of light, there's a formula for this. Of course, special and general relativity suggest that suitable geometries with spacetime or specific types of motion in space might allow time travel not only into the future but also into the past. However, time travel into the past is theoretically possible in certain general relativity spacetime geometries only when traveling faster than the speed of light is permitted. The problem with going back in time is forgetting about the other side of the coin of the spacetime continuum, which is space. It's not good enough just to travel back in time, you need something to propel you in space as well. So it's a spacetime machine, not just a time machine, because Earth is a moving target. I just want to make that clear. And by the way, just to go back in time, you could still land on Earth, But how has Earth rotated? You could end up in Siberia or in the middle of the ocean, probably, because most of Earth's longitude is spanned by ocean. So it's truth in time travel with regard to these spacetime coordinates. Now, we call these your coordinate in space and your coordinate of time, and we call it your world line. Another problem with going back in time using a time machine or a spacetime machine is the so-called grandfather paradox. But what is it exactly? You cannot go back in time and prevent your parents from meeting each other, because then you would have never been born to have gone back in time to prevent your parents from meeting each other. This is the fundamental paradox of time travel, and so if there were a rulebook, that would be the number one rule. Perhaps the best way to go back in time is to make use of wormholes. The theory of general relativity does suggest a scientific basis for the possibility of backward time travel in certain unusual scenarios. So going through a traversable wormhole could, in theory, allow you to go back in time. We have the fabric of the space-time continuum. It's not just that space is out there, space is intricately configured with time. And how do you know this? Space and time are forever conjoined. This fabric can be distorted in such a way that you can change the distance, the space-time distance, between two locations. One way to imagine that is, imagine all of our universe is just on a flat sheet of paper. You're on one edge of the paper, and I want to get to the other edge, and I'll take out light years of time, however long that takes. It's a light year's distance. So I take many years traveling at the speed of light. But if I take the space and warp it, curve it back on itself, now your location is very close to me. If I could somehow punch through the fabric of space and time and reach your location, something that would otherwise be a longer distance is now a shorter distance. And thereby transcending the speed of light to do so. You're no longer limited by the speed of light. The diameter of our galaxy is 100,000 light-years. You can't travel across it unless you figure out a way to warp space and time. So, in that warp, in principle, on paper, you can have a hole that you pass through and just come out the other side. And you're in another place, and if you did it right, you can show up at another time. And that's the most classical invocation of a wormhole. Another approach for backwards time travel involves a dense spinning cylinder, usually referred to as a Tipler cylinder. Discovered as a solution in general relativity, this hypothetical cylinder is infinitely long and spins fast enough about its long axis, and a spaceship flowing around the cylinder on a spiral path could travel back in time or forward, depending on the direction of the spiral. However, the density and speed required are so great that ordinary matter is not strong enough to construct it. By the way, if you manage to travel someplace faster than light, you have the capacity to move backwards in time. We've got that one established as well. We just don't have any easy way to travel faster than light. But one way that's been celebrated in science fiction, and you can write it out on paper legitimately, is a wormhole. A wormhole, I'm over here, and I want to get over there, and I want to get there quickly. You can travel through a wormhole that changes the effective distance between where you are and where you're going. And then you sort of look around when you get there and you find, oh my gosh, I've traveled 100,000 light-years in a matter of a moment. When you do that, you have the capacity to move backwards in time relative to when you left. Now, you don't get to visit yourself. You're in sort of a different space-time trajectory, so you can't shake hands with yourself before you left. And by the way, there's a huge paradox that people worry about, and many people, including the late Stephen Hawking, worried whether this paradox would prevent backwards time travel completely. Because if you go back in time and prevent your parents from meeting one another, then they wouldn't have ever given birth to you to go back in time to prevent them from meeting one another. Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this. Thank you.